Hello and welcome guys. Now in this video we will be learning about all the classification metrics that will be used for evaluating classification model. So previously we have learned about regression metrics. Now let's also learn about classification metrics. Okay, so first is accuracy. So this is the most basic classification metric that measures the proportion of correctly classified instances out of total number of instances. So the formula is true positive plus true negative. So I'm just wrote the short terms here, but just understand it. True positive plus true negative divided by true positive plus false positive plus true negative plus false negative is the formula for accuracy. Now example, let's say suppose we have a binary classification problem and with 100 instances our model classify 85 of them correctly. Then the accuracy would be true positive plus true negative by 85, which is our correctly classified, plus 5 plus 10 plus 0, which is our false positive, true negative and false negatives, which will give us 0.9, which will be then multiplied with 100 to get the percentage, which will give us 90% accuracy. Now to interpret this accuracy, high accuracy means that the model is correctly classified a large proportion of instances. However, accuracy can lead can be also misleading in situation where the classes are imbalanced or there is a misclassification. Okay, imbalance means there is 90% of data for class 1 but only 10% of data for class 2. So in this case there will be so many misclassification will happen, and that is the reason not every time accuracy is used. Then we have precision. So this matrix measure the proportion of true positive predictions out of all positive prediction. So the formula is true positive by true positive plus false positive. So example, suppose we have a binary classification problem where our model predict 50 instances as positive and 40 of them are actually positive. Then the precision would be 40 by 40 plus 10, which will give us 0.8 or 80%. Okay, so to show you mathematically, like I told you, we have 50 instances, okay, and 40 of them are actually true. So the formula will be 40 by 40 plus 10, which is misclassified, right? I mean they are not actually true, right? So it will give us 0.8, okay, which is 80%. Okay, so same way let's understand the other metrics also, that is recall. Okay, so recall, or it is also called sensitivity. So this metric measures the proportion of true positive prediction out of all actual positive instances. It is similar to precision but it's not. So the formula is true positive plus false negatives. In the precision we have used false positive, but here it is false negative. Okay, Fn. Now for example, let's say we have an example where there are 50 positive prediction, okay, and but there is actually 45 positive instances in the data. So then the formula will be if you want to put the value, it will be true positive, that is 40, out of which is 40 is actually true plus 5 is false negative, okay, and which will give us around 0.9, okay, or 0.89, something like that. So it will be our 90% result is giving. Okay, so interpretation will be high recall means that the model is correctly identifying most of the positive instances. So you can see that 90% of positive instances it has correctly predicted. So this is important in situation where false negative are costly, such as fraud detection. Okay. Then we have F1 score. Okay. So let's understand F1 score. So F1 score is like a harmonic mean of precision and recall that balances both metric. Okay, if you see the formula, it basically is the balance between recall and precision. So suppose we have a binary class problem, and where the precision is 0.75. Okay, precision is 0.75 and our recall is 0.85. Okay, then the F1 score would be 2 into precision, which is 0.75, into recall, that is 0.85, divided by 0.75 plus 0.85, which will give us around 0.8, which is 80%. So interpretation will be, if the F1 score is high, means that the model has good balance of precision and recall. It means that it is useful when the class are imbalanced. Okay, so like I told you, if the percentage of positive class and negative class is imbalanced, like 90:10 or 80:20, like that, in that case F1 score will be best to choose. And if we want to avoid over emphasizing either precision or recall. Okay, so this is what all the metrics are. Okay, so now there is also one metric, that is area under ROC curve. Okay, let's understand this as well. So area under the ROC curve, or you can say AUC-ROC curve, this metric measures the trade-off between true positive rate and false positive rate at different classification threshold. Okay, so what that means? So basically it means that high ROC, AUC-ROC means that the model is correctly identifying a high proportion of true positive while keeping false positive low. Okay, so it is useful when the cost of false positive and false negative are similar, and we want to choose a threshold that balance both. And you can see that a perfect AUC-ROC curve look like this. This one, more area you have, like this area, whole area, the more good the model is. Okay, just remember that. And you can see, here we have, for all the accuracy value, we have qualities. What is the result that we are getting. So if we are getting 90% to 100% accuracy value, which is very hard to get, then it is saying that we have a good model. Okay, and same way we have different scales. So this is what AUC-ROC score is for. It is used to compare multiple different models. So later on we will be seeing, we will be using AUC-ROC curve to compare logistic regression, random forest, other algorithms also. Then we have one more thing, that is classification metrics. Okay, so let me tell you about that, and then we'll understand this example. So this is like confusion matrix. So basically this is like a table. Okay, this confusion matrix is a table used to evaluate performance of classification model, and it summarizes the number of correct and incorrect prediction made by a model compared to actual label. So the formula in all the metrics that we have just now learned, all will have these particular values: true positive, false positive, false negative, and true negative. Okay, so a confusion matrix typically consists of 4 values. First is true positive. So true positive says the number of instances that are actually positive and were predicted as positive by the model. Okay, false positive says that the number of instances that are actually negative but were predicted as positive by the model. Then we have true negative. True negative says that the number of instances that are actually negative and were predicted as negative by the model, which is correct. Then we have false negative. So basically false negative says the number of instances that are actually positive but were predicted as negative by the model, and these all value that we will be getting out of classification model, we feed all this value to all the metrics and we get accuracy, precision, recall or font score. Hope this is clear. Now from these values, various evaluation metrics can be computed, like I just told you, all of these, including F1 score, recall. So these metrics help us assess performance of classification model and provide insight into where the model may need improvement. Overall, this confusion metrics provide a clear picture of how well the classification model is performing, including its strength, weaknesses. It can also be used to identify areas where model need improvement, such as where the misclassification happened severely for a given category. If we deep dive, we'll get information like that also. Okay, so yeah, that's all about metrics. Now let's focus into one example that I was showing. Suppose we have a binary classification problem of identifying whether a bank loan applicant is likely to default on a loan. So we train a logistic regression model on a data set of 1000 loan applicant, of which 800 are non-defaulters and 200 are defaulters. So after evaluating the model, we obtain a following confusion matrix. Okay, what this confusion matrix saying? So the actual label that we got 720 applicants, and the model also predicted no are 720, which means the model correctly predicted 720 applicants. Now there is predicted yes but actual no. So the actual label for 80 applications were no, but the model predicted wrongly these 80 applicants. Okay, then we have actual yes but predicted no, which means that the actual label of those 20 applicants were yes, but the model predicted no. So these are the point predicted yes, which is 80, and 20 where the model need improvement. Then we have this actual yes and predicted yes, which means that 180 applicants were actually defaulters, the model also predicted default. So this is what it means. Okay, now let's understand this table. Okay, so basically true positive rate is calculated as the ratio of true positive to the sum of true positive and false negative. So in this case, at threshold 0.1, we are getting 0.90 TPR, which means that 90% of actual defaulter are correctly identified by the model as defaulter. Okay, false positive rate is calculated as the ratio of false positive to the sum of false positive and true negative. In this case, 0.1, which means that 10% of the non-defaulters are incorrectly identified by the model as defaulter. So overall, TPR and FPR result suggests that the logistic regression model has relatively high sensitivity in the identifying defaulters, but also has a moderate level of false positive. This means that the model is effectively identify actual defaulter. It also it may also incorrectly flag some non-defaulter as potential defaulter. Further evaluation of the model performance, such as through use of other classification evaluation metrics such as F1 score, precision, which would be necessary to gain more comprehensive understanding of its strength and limitation. Lastly, I would like to add one more note here. So it's important to understand significance of this matrix. Accuracy is an overall metric for correct prediction regardless of class, whether it is positive or negative. The complement of accuracy is error rate or misclassification rate. High recall implies that very few positives are misclassified as negatives. High precision implies very few negatives are misclassified as positives. So there is a trade-off here. If model is partial towards positive, we will end up with high recall but low precision. If the model favor negatives, we will end up with low recall and high precision. So high specificity, like high precision, implies that very few negatives are classified as positive. So if positive represents some disease, specificity is the model confidence in clearing a person as disease free. Selectivity is the model confidence in diagnosing a person as disease. So ideally, recall, specificity, precision and accuracy should all be close to 1. On the other hand, false negative rate and false positive rate and the error rate should be close to 0. That is what we need from every model. Okay, so hope this is clear. Now let's move to the implementation part. So you will be implementing AUC-ROC curve of logistic regression, and we will be using wine dataset for this purpose. So let's jump into the coding part. So first of all, we will import all the necessary libraries. Import numpy, okay, load wine, then from Scikit-learn dot model selection, logistic regression. Okay, now we have to import all the metrics also. Metrics, accuracy score, ROC AUC score and ROC curve. Okay, now lastly we need to import the matplotlib also to visualize the plot. Okay, now let's load the wine dataset. Okay, wine.target. So we have loaded our wine dataset. Now we need to split the data into training and testing part. And test. Go to trend to split. Here we have to pass our xy, test size 0.2 and random state. Random state can be anything, so let's say 0. Okay, now we need to initialize the logistic regression model, so let's do that. So model equal to logistic regression, let's pass max iterate to be 1000. Okay, now model dot fit xtrain and our ytrain. Okay, now let's run it. So you can see our logistic regression has been trained successfully. Now what we need to do is we need to do the prediction. Okay, predictions. So ypred equal to model dot predict our x test. Now we need to do the accuracy calculation. Okay, accuracy, so accuracy equal to accuracy score, and here we have to pass our y test and prediction. Print accuracy. Okay, so you can see we are getting around 94% of accuracy. Now what we need to do is we need to create the probability for each of the classes. To do so, let's So that can be done using model.predict proba. Okay, it will give us probabilities. And here we have to pass our X test. Now if you print the proba, you will get all the probabilities. Okay, so these are all probabilities. Now let's calculate the ROC curve for each of the classes. So for that we need to define false positive rate as well as true positive rate. As you remember, we have a table for that in the theoretical session, so just remember that part. So we need to define FPR as well as TPR. So we will define it as an empty dictionary, and then we'll run a loop, and then we'll store it. Okay, so ROC AUC equal to dict. So we've defined all three. Now for I in range of 3, since we have 3 class levels. Okay, so FPR of I comma TPR of I comma underscore equal to ROC curve Y test equal to I Y prob I. Okay, now same for ROC AUC I So now if we run it and let's print out our FPR, so we will have probabilities of all the class labels. Okay, and for that reason we have done this step. Now what we need to do is we need to plot the ROC curve, and for that let's define the size of the figure first. So plt dot figure fix size equal to 8 comma let's say 6. Okay, so for I in a range of 3, plt dot plot FPR of I TPR of I W2 label equal to so I am giving dynamic labeling here, class of I AUC ROC AUC of I 2 decimal point. Okay, so we are done with plotting part. Okay, now one more thing, plt dot plot 0 comma 1 1 comma 0 color equal to gray, line style equal to dotted. Okay, plt dot xlim plt dot ylim. So this is limits. Okay, dot show. Okay, so what's happening in this code is, so first we have, um, uh, set the size of figure, which is 8 into 6 inches, which will be, a dimension of the plot. Then we are iterating over all the classes that we have. So we have like 0, 1 and 2 classes, and for each classes it will create a separate curve on the ROC plot. Okay, and in the next line what we are doing is, this line plot the ROC curve for I, class I, and the FPR of I is an array of, false positive rate. TPR of I is an array of true positive rates, and these rates determine how the model perform for class I. Okay, so at the labeling part, this part basically label the curve with the class number, example class 0, and then area under the curve AUC for that class. So AUC is the measure of model performance, and it displays the 2 decimal places. Now after that we are defining, uh, I mean so this line basically plot a diagonal dashes line from 0 comma 0 to uh, you know 1. So it represents the ROC curve, curve of the random, classifier, and provide a baseline for comparison. Okay, and in the next line we are defining limits. So these lines set the limit for x-axis, which is false positive rate, and y-axis true positive rate, uh, you know to ensure they cover the full range of possible values. And then we are defining our x label as well as title, legend, and then we are showing it. So let's run it, and it is saying TRP is not defined. Okay, it should be TPR. Okay, now you can see this is how our ROC AUC curve look like. Okay, and you can see that for all the classes we have our AUC score. Okay, since there is no variability in the model, you can see that it's 100% covering all the area, and that's why some of the classes not visible. So hope you guys understood how to implement AUC ROC curve, and okay, see you in the next tutorial. Okay, thank you so much for joining. See you tomorrow.